Hey y'all. Um, I hope everybody understood last week's lessons because I only had two people ask me questions, actually three. And I'm a little bit concerned that all questions were not answered. At this point, we are getting you ready for either the AP exam or your college professor. Um, to clarify, you may take the BC exam or the AB exam. You cannot take both. There is no sub score on the BC exam this year. So, there we go. I feel like that really needed to be clarified. I really miss you so much, and I wish I was talking to you face to face. This is so awful. Okay. Gotta get to work on the math, don't I? Okay, so far you've learned the P-series test, and not all functions are P-series. You've learned the direct comparison test, and not all functions have another function that is super similar to them. Oh, I'm talking weird. I'll just keep talking weird. And then there's the limit comparison tests, and you're not always going to be able to do that either. Um, And so, because you're not always going to be able to easily divide by something. So, and obviously not everything's an alternating series. I would hope you would recognize that. That one's kind of easy. Easy to recognize. So we're moving on to the ratio and roots tests. I'm sorry, I really can't talk. The ratio and root tests. It's not 2 in the afternoon and I still can't talk. Okay, by the way, my big slump of the day happens in the afternoon when I'm teaching you. Like, no matter what day it is, I am either napping or barely functional. So, we're going to go into the ratio and the root test, and we have some sort of series. Excuse me, I think I'm going to go drink some water. Oakley dokley. So, you have some sort of series of non-zero terms, and it's going to converge if the limit of the next term divided by the limit of the current term is less. It converges if the limit as n approaches infinity of the absolute value of the next term divided by the current term is less than 1. It diverges if the limit as n approaches infinity of the next term divided by the current term, did I say absolute value, is greater than 1. And if it equals 1, you need a completely new test, which we're going to get into eventually. I hope that would be obvious. So we're going to set A up so that we're taking the limit as n approaches infinity of the next term divided by the current term and see what happens. So there we go. There's our setup. Okay, we divide it out and we figure out, oh my gosh, I forgot my infinity. I'll put that in a second. That would have to be the limit as n approaches infinity of that whole thing divided out would be less than 1. Therefore, the series converges by the ratio test. Now, I got a lot of questions about that factorial, so I'm going to, 3 questions about that factorial. So I'm going to go over it real quick in the notes below this. Okay, I've broken down the steps, and hopefully now it is as clear as mud. Or clearer than, hopefully. That 2 to the n plus 1 can be rewritten 2 to the n times 2. Those two mean the exact same thing. And that n plus 1 factorial can be written n plus 1 times n factorial. So, another important piece here, I don't know why I said those words. Just pretend I didn't. Okay, so things cancel here. So 2 to the n cancels with 2 to the n factorial cancels with the n factorial. So all you're left with is that 2 and that n plus 1, which is what we had. up there. Okay. Okay, we're going to go through the same procedure on this one. This is a super easy test. We wish we could use it all the time, but we can't. Okay, as you can see, when we take the limit and we allow everything to cancel, that limit is actually 3/2. The limit of the ratio of the next term over the current term is 3/2, which is actually bigger than 1. So, that series diverges by the ratio test. Y'all, I made a right-o. I made that equals. That's not equals. I want to go back to the next slide, the previous slide, and make sure I didn't make that equals. Nope, I didn't. Okay, good. Okay. Moving on to the next bit. That one, when everything cancels, it's actually going to have a limit of infinity, and the series will diverge by the ratio test, and I'll do the work real quick. Okay, so for those of you still confused about factorial, here we go. I've written it out here. By the way, dividing fractions, why ask why, just flip the last and multiply. Only thing I liked about teaching 7th grade was that. Okay, so when we get to this one, when we finally flip the last and multiply, we see that we have this factorial over this factorial. So we need to break up our factorials, and these will cancel and those will cancel. And you need to understand how we got from here to there using what little you know about factorial. And I know some of you know very little, but hopefully me writing out that much helps you start to make sense of it, because it's really hard to talk about it without the numbers, and you seem to understand how to do it with the numbers. So that's not really the problem. The problem is like transitioning from the numbers to a more abstract representation. And I don't quite know how to get you there. It's very confusing to me to understand why you don't understand. I'm sorry. And while you're writing, I want to tell you something magical. There is this organization that is going to be playing live streaming. Oh, not live streaming. I'm sorry. They're doing some sort of pay-per-view for Calculus the Musical, which is probably a relatively fun way to review for the AP exam. So I'm going to post a link up on the BC Calc page for you so you can review by watching this ridiculous musical. I know that some of you are going to be all over that like white on rice. Musicals seem quite like Aiden's thing. I'm sorry, I should not throw him under the bus. I was trying to think of somebody else. Actually, you know what? Oh, no, can't think of who else. No, who would really hate it? Most of you. But anyway, okay. And here we go with the root tests. Da, da, da. Look at all that stuff going on there. Pretty simple. Obviously, it is so simple that you are expected to know it, but it rarely comes up because it's so easy. Of course, isn't that the way life works? If life was easy, would we be here sitting at home picking our bums? I don't think that's a weird thing to say, isn't it? Sitting on our bums, wishing we were at school instead. That's such a weird experience, I suppose. Okay, if we look at this one, we look and we see that the top of our function is actually a constant to the nth, well, to the 2nth, which is going to grow more slowly than n to the nth. So that has to be less than 1. Then we can say that that converges by the root test. When we take the limit of b, or the limit as n approaches infinity of the nth root of the absolute value of that a term of that series, you're going to see that that is going to be bigger than 1, and that will diverge by the root test. Okie dokie. So as you can see, that's going to be greater than 1 because the limit is actually 3/2. I didn't write that down, but it's not necessary to write it down. Moving right along. Okay. Oh, we just did that. And there's your assignment. And your assignment's also in Blend. Okay. So you need to read this. I am not going to read it to you because I assume you can read. And I'm supposed to be keeping these videos under 10 minutes, and I've yet to keep them under 20, and my goal today is keep them under 20. So please read this because I don't want to waste your time. It's not about my time, it's about yours. I'm trying to be careful about what I do with you or what I preach at you while I'm doing this. It is very weird on my end. It might be weird on your end too, but this is weird. Okay, so I really like Taylor polynomials and Taylor series. This is actually what your calculator is doing when it does things like try to figure out the roots or zeros or the max or the min, or it's actually how it graphs the sine function. It's using these approximations using Taylor polynomials to figure out how to graph it. So you actually need to walk into the AP exam knowing this stuff cold, but if you do the homework, you probably will not need to memorize it because it will kind of stick in your brain because you will have done it so much. Okie dokie. Okie dokie, artichoke. Sorry. It is a really weird experience telling really stupid jokes to myself and myself alone. Okay. I don't have anybody like groaning. Suppose that f is a function which has continuous derivatives and that f of 2 equals 3, f prime of 2 equals negative 4, f double prime of 2 equals 7, and f triple prime of 2 equals negative 5. Write the Taylor polynomial of degree 3 for f centered at 2. So you just use the formula, and the more you use the formula, the more sense it's going to make. And I'm going to write down what happens. Dun dun dun. Okay, so for your sake, I wrote down the actual. My stylus is being weird. What are you doing? Stop. It is so weird. It's trying to lasso everything. There we go. Okay. So I wrote down the actual formula before I began. This is a Taylor polynomial of degree 3. There is another way that they ask for Taylor polynomials. They may have asked for Taylor polynomial with 4 terms. This would also be a Taylor polynomial with 4 terms. Not to be repetitive, just to be clear. So, we have our Taylor polynomial of degree 3 centered at 2, meaning the closer you are to 2, the more accurate the approximation will be. Find the Taylor. Next we move on to find the Taylor polynomial of degree n equals 4 for f of x equal e to the 3x at 2. Now there's a difference here. In this one, it asks for this stuff, and it didn't give you the stuff straight out like it did in the previous thing. In the previous thing, it actually went out and said all of this gibberish, right? Well, that's sloppy. Let me try to fix that so I don't have to deal with that some other time. Okay. I just keep thinking about Stephanie giggling at my really idiotic jokes. I'm sorry, guys. She's the only one who appreciates me. Nobody else appreciates me. Okay, there. See, it doesn't have all that stuff. So we actually have to go in and calculate all of these derivatives. Ugh. Okay, in front of you here, there is something that I don't think we saw. I don't remember pointing it out to you before, but if you look over here on the far right, you've got the fourth derivative. And notice that little 4 up there, right? I don't think we did that before. I really don't. And I want you to know that if you go farther than the third derivative, you put that tiny little like exponent, it's a superscript. It looks like an exponent, but it's in parentheses. So if you get to the AP exam and you need to talk about something crazy like the fourth derivative, that's how you do it. Or that's how you write about it. Because please don't start talking. Oh, you're going to be by yourself. You can talk about the AP exam all you want. Once we figured out all of our derivatives, then we figure out what the value of those derivatives would be at 2. Once we figured out what the value of those derivatives would be at 2, we create our Taylor polynomial centered at 2 of degree 4 using the formula that was listed at the top of your page. Also, I forgot to talk about a Maclaurin polynomial, which we will be talking about on the next page. Maclaurin polynomial is just a Taylor polynomial centered at 0. And professors definitely expect you to be able to distinguish between the two titles. There's our setup using our formula. Now all we need to do is use the information that we found in the calculations in the first 2 lines and use that in the new Taylor polynomial. And there we go. There is our beautiful Taylor polynomial of degree n equals 4. Oh, oops. Now we're going to find the Maclaurin polynomial of degree n equals 5 for f of x equals sine of x. So we need to find all of those derivatives all the way out to degree 5 and then use our formula and plug those values in. Nancy Drew's up here trying to talk to you, but her purr is really quiet and it wouldn't record, so I've tried. Okay, there we go. So, back in the day, I used to skip like this whole bit right here, and it would super confuse people. So I no longer skip it because I think it's important that you understand where all of that came from. Boy, I'm bad at drawing those boxes, aren't I? Anyway, so what you're doing down here is you're using your calculator. I'm sorry. Yes, that's all there is to it. I'm so sorry. I kind of skipped without articulating that. So now we're going to go on to B and C, and this is all in your calculator. You're going to use your calculator to find the Taylor polynomial series value at 1.4 and the function's value at 1.4, and that helps you figure out the error of your approximation. And you also figure it out at 2.1. Well, what you're going to notice is that the error at 2.1 is going to be greater than the error at 1.4 because, dun dun dun, it's a Maclaurin series, so it's centered at 0, and 1.4 is closer to 0 than 2.1. Okay, make sure that your calculator values match with my calculator values for the approximations, the actual function values, and the errors. And make sure that you understand that the farther you are away from the center, the more, the greater your error is going to be. Finally, I found this on the Twitterverse and I thought it was really cute. But also, this guy has too much time in his hands. Don't we all? So, now we know how calculus was invented. I don't know if you've caught that it was invented during, I believe it was the bubonic plague. Y'all have a great one. Can't wait to see you in the Zoom room. Take care. Bye-bye.